Hello everyone, welcome back to Encodex Education. I'm so glad you are here. In our previous lesson, we explored shell scripting and learned how to make simple things happen automatically, with loops and conditionals. Today, we're jumping into the world of Git collaboration, with a focus on version control fundamentals, from how to start a Git repository all the way to making changes and created branches. Don't worry if you've never used Git before. We'll walk through every single step together. In our next lesson, we'll see how teams use Git to do fancy things like pull requests, fix conflicts, and host their code online. But right now, let's dig into Git's basics. Git is a program that helps us keep track of changes in our files. Think of it like a super smart time machine for code. If you make a mistake, Git can help you go back to an older version of your work. If you want to try new ideas without breaking your existing project, Git helps you create a separate branch to play around in. Then, when it's all good, you can merge it back. Before Git, people used other version control systems. But Git became really popular because it was created by Linus Torvalds, the same person who made Linux. He wanted a system that was fast, let many people work on the same project, and let everyone keep their own copy of the code on their computers. That way, they didn't always have to be connected to a server. This design is called a distributed version control system, which is just a fancy way of saying that every user has a complete history of the projects. So it's super fast and doesn't rely on one central computer for everything. Under the hood, Git works by storing snapshots of your projects. Each snapshot is like a picture of how all of your files look at a certain time. When you make a commit, which we'll talk about in detail soon, Git saves a new snapshot. If you ever want to see how your files looked before, Git can show you the older snapshot. The magic is that Git only saves the parts that changed, so it doesn't get too big. First, we need to make sure Git is installed on your computer. If you don't have Git, you can visit git-scn.com, download and install it like you'd install any other program. But let's assume you've done that. Now open your terminal or command prompt so we can start typing commands together. Let's create a brand new folder. Since we want to start fresh, you can call it anything you like. I'll name my Git project. To do that, in your terminal or command prompt, you can type make dir, actually we are using PyCharm here, make dir my Git project. That tells your computer to make the directory named my Git project. Next, we go inside that folder by doing cd my Git project. Perfect. Now we're ready to make this folder into a Git repository. A Git repository is basically a place where Git can keep track of all our snapshots. To create this repository, type git init. Perfect. As you can see, initialized empty Git repository in our actual folder. This command creates a hidden folder called .git inside our project. That folder is where Git stores everything it needs to manage version of our files. You usually won't need to touch that folder directly, but it's important to know it's there. To see Git in action, we need at least one file. Let's create a file called hello.txt with some text in it. We can do this using a text editor or by running a quick command. I'll show you a command that works on many systems. Echo hello world hello.txt. If you open the hello.txt file, you'll see it contains hello world. Great, we have a file now. Let's see. Cut hello.txt. Perfect. Git has a handy command that tells you what's going on in your repository. That command is git status. When you run it, Git will say something like untracked files and the name of the file, hello.txt. This means Git sees a new file, that's it, not you yet watching. In other words, we haven't told Git to save a snapshot of this file. Before we can save a snapshot, commit, we need to stage the file. Staging is like telling Git, I want to include this file in my next snapshot. To do that, we type git add hello.txt. Now, hello.txt is in the staging area. If we run git status again, Git will say something like changes to be committed hello.txt. That means Git is ready to commit hello.txt in our next snapshot. Let's try. Git. Perfect. As you can see, exactly what I have explained to you. A commit is basically a record in Git that says, here is how my files look right now. Each commit has a message which helps us remember why we made the changes. Let's commit our files. To do it, we do git commit -m to add a message, and we do add hello.txt with a friendly greet. Perfect. The -m part stands for message. We wrote add hello.txt with a friendly greeting because it describes what we did. If everything went well, Git will say something like one file changed, one insertion. Exactly what we see here. Now, if we run git status, Git should say everything is clean, meaning there are no more changes for it to track at this moment. Let's try. Git status. Perfect. When you make a commit, Git creates a snapshot of how all your tracked files look. It also assigns each commit a weird-looking ID, which is actually a special code made with cryptography. This code helps Git know exactly what's in that commit. Under the hood, Git is storing all the text in a compressed format. But that's not something we usually have to worry about. The important thing is that Git can always tell if someone tried to change a commit behind your back, because the ID will no longer match. That's one big reason why Git is so good at keeping track of changes in a secure way. Let's make a small update to our hello.txt file. Maybe we want it to say something else. We'll open the file in our favorite text editor and change the content. For instance, we will do nano hello.txt and we will delete this and put hello again world. We are learning Git. We save doing Ctrl X, Y, and Enter. And now, if we do git status, it will say something like there is a change to hello.txt. We have to add it, stage it again, so Git knows we want to commit it. So let's see. Git status. Perfect. As you can see, the file has been modified. Now we do git add hello.txt so that we tell to add it to the next commit. Now we said to Git that we want to commit this file. Then we commit by doing git commit -m update hello.txt with a second line. Perfect. Now Git has recorded that change as a second snapshot. We can keep doing this for every change we make, building up a history of commits. If you want to see our commit so far, we can do git log. This will list all the commits, starting with the newest at the top. Each commit shows the commit ID, the author, the date, and the message. If you get an error saying please tell me who you are, it means Git doesn't know your name or your email. To fix that, we can do git config -- global user.name, and you put your name. For example, Shafiq is my name. Perfect. And for the email, we do git config -- global user.email, and we put Shafiq at example.com. Perfect. Then you try to commit again. Now, let's talk about branches. Think of your project as a big tree trunk, the main branch. If you want to work on something new or risky, you can create a new branch that sprouts off the trunk. That way, you don't mess up your main project if things go wrong. Once you're happy with your changes, you can merge your branch back into the main branch, so everyone else can benefit from it. Git makes branching super easy, which is one of the reasons it's so popular in real companies. For example, if a big company wants to develop a new feature, they'll create a new branch, do all their work, test it, and then merge it back. If they found a bug, they can fix it on a short-lived branch, test it, and merge. That's how big teams keep their projects organized. Let's create our own branch called Greeting Update. We can do that like so. Git branch Greeting Update. If we run git branch with no extra arguments, it will list our branches. We'll probably see main or master, depending on Git's default on your system, and greeting update. The one with a star next to it is our current branch. Let's see. Git branch. Perfect. If the star is next to master, we need to switch to our new branch by doing git checkout greeting update. Now we're in the greeting update branch. Any changes we make here won't affect the main branch until we merge. Let's create a new file to show we're working on something separate. We'll call it notes.txt. Let's type echo. Those are notes for our greeting update. Let's put these texts into notes.txt. Let's check our status by doing git status. It will say untracked file notes.txt. So let's add and commit it by doing git add notes. And then let's do the commit. Git commit -m add notes for greeting update. Now notes.txt lives only in the greeting update branch. If we switch back to main, that file isn't there. To switch back, we do git checkout main. I'm sorry, git checkout master. Perfect. If we list the files in the folder, we won't see notes.txt. But don't worry, our changes are still safe in the greetings update branch. That's the beauty of branching. Let's check. As you can see here, we have hello.txt, but we don't have notes.txt. We want to bring the changes from greeting update back into main or master. So everyone, or just us for now, can see them. First, make sure we are on main by doing git checkout main if you have a main, or master in my case. Now we merge by doing git merge greeting update. Perfect. Git will say something about a fast forward. That just means Git moved the pointer of the main branch forward to include our new commit, because there were no conflicts. Now, if we list the files, we'll see notes.txt. Congratulations, we just merged a branch. So let's do ls, and we can see both the files. We've covered a lot. Git init to start a repo, git add to stage a changes, git commit -m and the message to create a snapshot, git status to see what's happening, git log to look at commit history, git branch and the branch name to create a branch, git checkout and the branch name to switch branches, and git merge and the branch name to merge a branch into the one you're on. If you remember those commands, you can do most of what people do with Git in real projects. Big companies like Google, Microsoft, and Netflix use Git. They often have many branches for new features, bug fixes, or experiments. They also have big histories of commits, so they can track all the changes that have happened over the years. To show everything in one clean sweep, let's quickly create another branch, make a change, and merge it. This time, we'll also show super detailed comments explaining each line in a single code file. Let's say we want to rename hello.txt to world.txt. We can do that on a new branch. First, we create and switch in one go. Let's do clear git checkout -b for branch and rename file. Now we rename the file by doing mv hello.txt world.txt. Perfect. Let's stage this rename by doing git add hello.txt world.txt. Git sees this as a removal of hello.txt and an addition of world.txt. Let's commit git commit -m rename hello.txt to world.txt. Perfect. Then we merge back into main by doing git checkout main git merge rename -file. I'm sorry. Git checkout master, and we merge back into master. So we do git merge rename file. Perfect. Now we see world.txt in our main branch. If we open it, we see the same content that was once in hello.txt. Git is so good at tracking changes that it understands we renamed the file rather than deleting and re-adding a file. This rename process helps keep the history connected. For fun, let's add a tiny Python script called great.py to see how Git handles code. We'll do everything from scratch and show each line. So let's do clear nano great.py, and let's do print hello from Python. Close it and save it. Perfect. Now let's stage and commit git add great.py. Perfect. And git commit -m add simple great.py script. Perfect. Now let's open great.py and add more to it. I'll show you a more thorough version with detailed comments. Type this into your favorite editor. So let's do nano great.py and let's delete this and do def great brackets print hello from the great function. Perfect. And we do if name equals main, then run the great function. This is a simple Python script that prints a greeting. We'll commit changes to this file to see how Git tracks them. This function prints a greeting message to the screen. And this is the starting point when we run greet.py directly. We call greet to see a friendly message. So let's save. Make sure you save this file. Now we stage and commit those changes again by doing git add great.py and git commit -m enhance greet.py with a greet function and comments. If we want to run the script to test, we can just do Python or Python 3 and the name of the file. So Python 3, as you can see, it runs the function. It will print hello from the great function. If we want to add more lines or fix a bug, we can do so and then create a new commit each time. That's the power of version control. We've seen how Git is made to store snapshots of our work, so we can go back in time if we need. We've also learned how to create a repository, track changes, commit them, branch off for safety, and merge. Real companies love Git because it's easy to branch, easy to merge most of the time, and it keeps your work history safe. That's it for today's lesson on Git collaboration basics. We learned how to initialize a Git repository, stage and commit changes, and create and merge branches. In our next lesson, team workflows, pull requests, resolving merge conflicts, and Git hosting platforms, we'll see how to handle bigger group projects. We'll also explore how developers share their work on sites like GitHub or GitLab, and how to manage conflicts when people change the same file at the same time. Thank you for joining me here at Encodex Education. If you enjoyed this, please give us a like, subscribe to the channel, and stick around for our next adventure in Git collaboration. Happy coding and see you next time!